Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about the database architecture, that how the database should be structured. First we will discuss about the system structure of the database, and next we will discuss about the client server architecture of a 2-tier and 3-tier one. So now that we have described all the components of a database, all the conceptual designing, schemas, the logical level, view abstraction and all, so we can say that the system structure and the components, how they are actually best and relationships among them. So first we will know and discuss about that. So here at the outer level, we can see that there are 4 types of the users. One is the naive users, application program, sophisticated users, and database administrator. So we can see that all this among the users, only the application programmers can write the application programs, while all the naive users, the sophisticated or the analysis users, the database administrator or the specialized sophisticated users can use the tools. So that is the main difference between the architectural difference. So first one is the application programmers can write the application program and other users can only use the tools. Next, we can see that the naive users are using the application interfaces or the application programs by which we can communicate with the database systems. The sophisticated users directly uses the query tools, and the administrative users like the specialized users can use the administrative tools like the authorization and all the administrative ideas. So these are all for the user part and the administrator part. Now we are moving to the actual DDL interpreter or the DML compiler, that is the storage manager and the query processing on the querying task. So in this way, the application program object code is first generated, then the query evaluation engine produces all the query plans that can happen on that particular database. So there can be many query plans on a particular database, and the query evaluation engine then generates the query optimization code, which is helped to get the best cost-effective query plan to choose among them to get the best result. Now after the compiler and linker, the DML queries are given, so the organizer again gives it to the query evaluation engine, which generates the query. So the compiler and the linker given the program object code. Now here comes with the DDL interpreter that is directly linked only with this database administrator or the DBA. So again it will be given to the DML queries, and now it will be again given to the compiler, and it is given to the query evaluation engine. So that is part of the querying. Now we will move to the storage manager, as we have said. So the storage manager are said the authorization manager, file manager, buffer manager, and the transaction manager. So the authorization and integrity manager directly deals with the data dictionary and decides that which part of the data should be given to which of the users. Now that the application manager or the authorization manager deals with the data dictionary, also the statistical data that is given to the file manager. So the file manager helps with the indices that directly points to the data. Say for an instance, if an ID of an employee is given, so within the help of that ID, we can generate all the tuples or the attributes on that particular ID, say the salary, employee name, address, contact details and all. So the buffer manager manages the data on the main memory to the buffer area, and then the transaction manager generally manages the transaction, that is the atomicity and the atomicity or the consistency. So this is the basic system structure of that particular DBMS or database system. So the main area is the disk storage, storage manager, query processor, and the user and the administrators. So in this way we can describe the system architecture. As we know that the days has evolved, we have now been moved from the distributed DBMS from a centralized DBMS. So on a centralized DBMS, the database applications and the clients who are using the database residing on the same system. So depending on the computer system which is running the DBMS, the system architecture generally changes a little bit. Now for a distributed DBMS, there is a client and server relationship often. When we are providing a client and a server relationship, we can say that the database applications are not residing in the same system that the database which is residing. So here, the clients are the application programs which will try to access the database that is residing on a distributed or a remote computer system. And server is a machine which is serving the database and getting retrieve the information and sending it back to the application program. So that is basically the structure of the client server system. And in a centralized system, as we have said, that there is no need to pass on the details of the computer systems because all the applications and the database residing on the same system. Obviously, distributed system is more effective than a centralized system because there is a burden or that's overcome. So the distributed system is having more than one computer. So if there is any failure on the client and the server machines, so that another client can serve to the server. So now we will see that how the client server architecture is handled in two ways. In a client and server architecture, in a two-tier one, we have two tiers of client and server. The client has a user which also has an application which will interact with the database over the network, and the database system is residing on the server one. So here we can put that is the user and the application which can together known as a client. Now that the client is residing and communicating with the server with a network. So the database system will be known as a network and the server. So this is a basic two-tier architecture where the client is having is a user and the application program which is needed to communicating over the network through the database system and the server. Now we will move to the higher level of architecture, that is a three-tier level architecture. In the three-tier level, the client itself is doing nothing other than being a user or having the result. And it initiates an application which is also a client. Now the application part of a two-tier architecture is converted to the application client which is a part of the client, and then it will invoke an application program which will move and communicate over the network through the server in the database system is residing on. So it looks like so here the client program is the user which is initiating another application client which will communicate over the application server in the network and then directly communicating with the database system that is residing on the server. So the three-tier architecture is a more combined and embedded one where we can say that is used for the large applications where the client is the application one and it initiates another application program to communicate over the network, so that the burden and the overhead of having the application as well as being the user is just avoided by keeping another application client and server program to the three-tier architecture. So this is the basis database architecture for the system architecture part that we have already told, and this is the client server architecture that is being used normally hugely. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.